Oh, yesterday we talked mean value theorem. What's the big idea in plain old English of the mean value theorem? We're finding a place where secant slope equals tangent slope. Perfect. Or average rate of change equals instantaneous rate of change. Yeah? Okay. Now, in the book problems, they'll typically give you an equation to work with, and you do a totally different problem. In AP problems, they typically give you a table to work from. These are commonly table problems. So the idea is this. They're giving you a bunch of function values, and they ask a question something like this. Must there be a c in 0 to 8? Now, c is an x value in the region they're talking about. They say the x's go from 0 to 8. So is there some x value in there where the instantaneous rate of change is -2? Now, it's hard to say how, I mean, if without knowing the mean value theorem, you might say, yes?
We are missing 3.
I'm missing 3? Oh, you don't have, like, this column?
No, they don't have them.
Oh, you're missing 3. Oh. Silly me. Oh, that's why I have so many. I felt like that. You need a lot of extra compensation. Oh, well. Okay. Sorry. Okay. So, the idea is this. We don't have an equation to work from, so it's hard to find the derivative equal to -2 or set the derivative equal to -2. The intention is that you try and find 2 points where the average rate of change or secant slope is -2. So that we can say, oh yeah, there's an MVT thing going on here. The slope between these 2 points is -2, so there's got to be a place where the derivative is -2. Right? So we'll find that place, and then we'll say it all the proper way. We'll go from there. Now, it's most common on the AP test that they use the endpoints. But when I say the average rate of change, I'm talking change in F over change in X. And here, the change in F is down 5 over 8, yeah? So -5/8. It's not those points, obviously, the change over that is -5/8. So we're going to have to do a little more thinking. We're going to need to find somewhere where there's 2 points where the average rate of change is -2 over 1. So do you see, how about, let's just go these two. If I look at the slope here, it's up 2 over 2. That slope is not -2, like I'm looking for, all right? In fact, we really need to start by looking for where the y values decrease. So how about here, these two guys? What's the slope between those two? It's down 2 over 1. It feels like that's the interval where the average change, the change between 2 points, is decreasing at a slope of 2 over 1. So there's got to be a point in that interval where the instantaneous slope is always also -2. You with me? All right. So now let's talk about saying it. In order to use the MVT, a lot like intermediate value theorem, you have to show the conditions were met. So what are the 2 conditions for MVT? Continuous and differentiable. Okay, so say something like F is continuous and differentiable. Now, actually, they don't really say it's continuous. How do I know it's continuous? Differentiability implies continuity. If the derivative exists, it has to be continuous. All right, so it's implied. F is continuous and differentiable. So by MVT, there is a C in. Now I know they said 0 to 8, but I'm going to go more specific and say where the one we're looking at is. Yes.
So for a real AP test, would we say it's continuous because it's differentiable? Or
That's a good question. Do you have to justify why you say it's continuous? And they're pretty lax on that. They'll go with the implication because they gave differentiability, you can say. That's a good question. So by MBT, there's a C in what interval are we looking at? 2 to 3. This is where we saw the rate of change going -2. So we'd say there's a C in 2 to 3 where f prime at C equals, now this is where we actually have to show where we're coming from. We don't just say, hey, -2, take my word for it. We have to show the average rate of change part over here. So when we said the slope was -3, we got that by saying f at 3 minus f at 2 over 3 minus 2. That was where I got -2. And you do have to kind of show where -2 came from. You follow? Okay. Try this one then, please. I understand we just met the conditions, but you just get practice by stating the conditions were met again, just to, feed it into it. Is there one here? Do I mean this to be a trick question? No, I would not throw a trick question as you are. I think I just screwed up. There's no place where the change is -1, is there? Where? 0, 2 is +1, isn't it? 3 to 7. Isn't that down 5 over 4?
0 to 4.
0 to 4. 4 over 4. There you go. You got it. Okay, so it is there. I didn't have a trick question. Thank you. Okay, so 0 to 4. And then say it well. So we say we're going 0 to 4. Down 4 over 4. All right, we good? Try the next one. Hopefully you'll do better than I did. I didn't even see it. This one's a no?
No, there's like this question.
There's not that, this question's not there?
Yeah.
It's not there. Oh, I'm sorry. Okay. Is the relay question there?
No.
Okay. Let's just say it. Is there a point that satisfies the Rolle's theorem? I know it's not on your paper. Just talk to me. What is Rolle's theorem, or what subcategory is it? What's more specific? It's still rate of change, but the rate of change has to be 0. So is there a case where that happens? Where the average rate of change would be 0? The answer is yes. In fact, there are 2. Here, the average rate of change is 0, and there. So yeah, you could actually find 2 points by Rolle's theorem where the instantaneous slope must have been 0. All right. Now then, let's jump back to page 1, please. Are we what? Oh, there's another part? Oh, yeah, no, I want this. Sorry, just a second. Obviously, I didn't import the change slides. Is this the part? You have a part of a horizontal tangent, yeah? Okay, so let's go there. Sorry, example 3. I think that's where I changed the latest to. Example 3, prove there's a horizontal tangent. Are you with me? Sorry. Okay. Let's get out the old calculus decoder and put that into calculus. What does horizontal tangent imply? Horizontal tangent implies there's a place where what? Slope is 0 or the derivative at some point is 0. So if we were to put this in MVT terms, we're trying to prove there's a point where the derivative must be 0. Okay? Then it becomes like a MVT problem. We say f is continuous and differentiable. So by, talk to me, spit, somebody yell it out. So by MVT, there is a C and, give me an interval possible. Where is there an interval? 7, 8? 7, 8, sounds good. And 7, 8, where f prime at C equals f at 8 minus f at 7 over 8 minus 7, which is 0. Okay? A harder case, so those are pretty straightforward AP style. Knowing AP, then they sometimes throw you some where you have to do a little second layer of thinking here. So look at this one. F is twice differentiable, which is to say f prime and f double exist. Prove there must be a point where f prime is 0. Now, if you look at this, there's no place here where the y's are the same. So there's no place that's obvious where it feels like, oh, average rate of change is 0. So it's tempting to say there isn't one because there's no place where the y's are the same. There is, however, a place where y is 0 or the derivative is 0, and you can prove it. Let's talk here. Here, f is decreasing, yeah? So what does that imply? That f prime must be negative. Now, does that imply f prime is negative everywhere there, or it must be negative somewhere? Somewhere. All right? But then it starts to increase. And if f is increasing, that implies that f prime must be positive somewhere. Now, if f prime goes from negative to positive, must be the case that f prime had been 0. Yeah, by what? IVT. So this actually is a problem of 2 layers. There's an MVT layer and an IVT layer. And that one is the one that separates the good from the great. So we're going to be great. So this is going to go something like this. Let's start by finding a point here by MVT and this point by MVT, and then we'll do the IVT. So it goes a little something like this. F is continuous and differentiable. So by MVT, there is a C in, let's go in 0 to 2, such that where f prime at that C is f at 2 minus f at 0 over 2 minus 0, and how does that pan out? What is the slope there on those 2-point intervals, or that 2-point interval? Negative 1/2. You see where we're coming from? Okay, great. So I established there's a point where f prime is negative. I could also say, I don't have to do the conditions again. I could say similarly, there's a, now I can't call it C again, so I'll call it, there is a B, okay? B in Now I could go a lot of different intervals because f is increasing. I could go 2 to 3, 2 to 4, 2 to 6, it doesn't matter. But there's a b and let's just go 2 to 3 such that f prime at b is f at 3 minus f at 2 over 3 minus 2, which is, and what's that slope between 3 and 2? Up 3 over 1, okay. Now, we just established that there's some point in 0 to 2 where f prime is negative. And there's another point in 2 to 3 where f prime is positive. It can't go from negative to positive without passing through 0, assuming that f prime is continuous. Is f prime continuous? Why? Yeah, if it's twice differentiable, that means the second derivative exists. And the second derivative can't exist if f prime wasn't continuous. Okay, so you'd say something like, because f is twice differentiable, that means f double exists, which means f prime is continuous. By IVT, there is a place where f prime is 0 because, and what's the last part of IVT I need to say or show, demonstrate? IVT is all about the betweenness, right? Okay, so there is a 0, there is a place where f prime equals 0 between what and what? Yeah, f at c, which is f prime at c, which is negative a half, and f prime at b, which is 3. If you just said because negative, you would be okay here. I feel like the previous one's better, but the betweenness is what you have. Are you with me? All right. Is this the next place in your, is this on yours?
Yeah.
Okay. All right. Also a little gross that sometimes you're asked to do. Must there be a place where this second derivative is 0? Did I give you anything about this? Perhaps I should give you that f is twice differentiable. F is twice differentiable. Okay. This is a humdinger. So, must there be a place where f double is 0? The temptation is students want to go concavity here. It's not about concavity. It's about change in the change. Let's forget f double right now. Can you tell me, is there a place where f prime is 0? Must there be a place where f prime is 0? Yes. How many? 2. So there's probably a place in here, let's call it C, where f prime is 0, and later on there's probably a place in here where f prime at maybe B is 0, yeah? Because later on it ends up in the same y value. Now, think of this as like a new table. If f prime was at 0 and later at 0, then doesn't that mean that the average change in f prime, which is f double, must have also been 0 and somewhere in there, yeah? All right, so there must have been some f double at A, the 0 in there. Now that's the approach. Now we just have to put it all together and say it the right way. That's our outline of the problem. Are you with me so far conceptually? Okay, so here we go. F is twice differentiable, so f is continuous and differentiable. You don't have to. It's kind of given, so you just say f is continuous and differentiable. So by MVT, again, say it for me. There is a C in when, in where, in what interval? 0 to 5. Where or such that? More, please. F prime at C is 5 minus f of 0 over 5 minus 0, and that is a slope of 0. If you're using it again in the same fashion, you don't have to redo everything. You can just say similarly. The AP is fine with that. Similarly, there is a, we don't want to use C again. We need to use a different name. So it'll be in 5 to 8, where f prime f at b is equal to the average rate of change, which is change in y, or change in the f values, over change in x, which is the change between 8 and 5. And that slope was 0, right? Now this is the, for a good student, this is the part that's the least like, or the most likely to cause the problem, all right? So now we're going to apply the MVT to f prime. So how are we going to cite the conditions here? To use the MVT on f prime, I have to say that f prime is continuous and differentiable, and that's because f is twice differentiable, right? Because f is continuous or twice differentiable, f prime must be continuous and differentiable. In other words, I can take the derivative of f prime because f double exists. So there is a what? A. That's weird. There is an A. There is an A. There is an A. That sounds better. Sounds a lot better than there is an A. There is an A in where? Too bad. 0 to 8 is true, and they wouldn't take you off, but too bad. Nope. Where? Where does it happen? What are the endpoints you're using? C and B. Those are the endpoints you're using, right? There is a in C to B where f double at A equals f double is the change in f prime, so f prime at B minus f prime at C over B minus C, and therefore there must be a place, we call it A, where f double is 0, because 0 minus 0 over whatever C is. Are you with me? That's pretty rare. That's maybe been twice in the last 15 years that they went double level of MVT. That's pretty rare. Okay, let's go to the front side now. The hard part that sometimes happens is that they'll give you a question A and a B and a free response that, oh, they're so close. They are this close from being identical. And you attempted to think they're not even the same. So if you were to look at this here, this little table, they would never give you a table this small, but it satisfies the shared point. There might be a question saying, must there be a C such that f at C is 1? But they might also say, must there be a C such that f prime at C is 1? Those are two totally different questions. What is this question asking? What's the idea? It's must there be a y value that's 1, not a rate of change that's 1, a y value. What is it? If it went from here to here, must it have gone through? What is that a reference to? IVT. That's an IVT question. No prime. Y value. That's IVT. Now, I don't know if I made it or put this. Does IVT guarantee such a point? No. Okay. So this is I should have made it so you could do both but for different reasons. That was dumb. Can we change this? What do you think?
No.
Yeah, we can. Okay, let's change this to 0 to 2. All right, now then, when I change that to 0 to 2, the answer will be a yes, but it'll be a totally different yes reason than the next one. Okay, so if we're going to use IVT, what's the condition for IVT? F is continuous. It's given as twice differentiable, so that definitely implies continuous. You don't have to say why you say it, you can just say it. F is continuous, and let's also go the betweenness. 1 is between 0 and 2, so by IVT, there is a, I just regurgitate the question out of them. There is a C in 0 to 2, in 0 to 2, where F at C is 1. That's talking, must there be a Y value, not an average rate of change, not a derivative value, a Y value, right? So that's IVT. This one, I copied and pasted, and I just stuck in the smallest little prime in it. But that makes the problem very different. Now you're talking, must there be a place where the instantaneous rate of change equals 1? That's a reference to MVT. You're talking rates of change now. So meet the conditions. What are the conditions for MVT? Yeah, F is continuous and differentiable. So by MVT, there is a point C in 0 to 2 where F prime at C is, we can't just say, yeah, it's 1. We have to show that we understand the idea. So the instantaneous rate of change equals the average rate of change. What does it look like? F at 2 minus F at 0 over 2 minus 0, and that is indeed a slope of 1. Slope between the endpoints is 1. There's got to be somewhere in there. I don't know what it's doing between those 2 points, but there's got to be somewhere in there where the slope is 1, right? Compare that to the last existence theorem, which doesn't really need to see, but I just want to review it. Must there be a C in 0 to 2 such that F at C is greater than or equal to F at X? Put that in plain old English. 2 words. That means they're saying prove there is an absolute maximum. Okay. They're saying, is there a Y value? Is there some X value that makes a Y value greater than or equal to all other Y values? Okay, that's in plain old English. Y value greater than all others. That is the extreme value theorem, which is to say, must there be an absolute max? I don't know if you remember this. Do you remember the conditions for having a guaranteed absolute maximum? There are 2 conditions. It's got to be continuous on a closed interval. Okay. If you have endpoints and it has to go smoothly from one point to the other, it has to have an absolute maximum. It can't be this kind of dealio where it's going like this and there is no absolute maximum. It can't be whatever. It can't be someplace that just goes on forever. If you close it off and it's continuous, it's got to have an absolute max. So you'd say something like, because F is continuous and a closed interval is given, there must be an absolute max. That is not very common. That's pretty common on a multiple choice, but they don't actually have you write the EVT very much. Okay, that's the extreme value theorem. Would you write that? Our book calls it the critical number theorem, which I've never seen in any other textbook. Most textbooks call it the extreme value theorem. Okay. Let's do We're getting there. We're almost done. Sorry. I'll stop yapping in a second here. So sometimes I'll throw IVT and MVT together in interesting and fun ways in a math fun sense. Given the position of velocity function, both are differentiable. Must there be a time when the particle is at rest justified? All right. Now, this is a classic trap problem. Must there be a place when the particle's at rest? Let's first decode that. Rest means what's happening. What's zero? Velocity is zero. Okay? Now the temptation is to look at this velocity row and say, well, shoot, those are all positive. 2, 3, 4, 1. No, velocity's not zero. There's no IVT going on, right? So when I say, does the IVT sim indicate such a point, the answer is no. Zero's not between any given values. Now, I'm not, again, never read too much in a table. Just because they're all positive doesn't mean it couldn't have sometime gone through zero, right? I don't think just because the table seems to say positive means it was always positive. Just as far as what the table shows, it doesn't show that it's zero. Look at the MVT. Now, MVT would mean is there an instant when the change in position is zero? So what I want you to do is, instead of looking at the V row, look at the X row. Was there any pair of points where the net rate of change was zero? Yeah, from 0 to 8, the overall average rate of change is positive or 0, and so there must have been a place where V was 0. You can think of it this way: position was increasing here, V was positive, then decreasing negative. It must have been 0 in there somewhere. If it went from increasing position to decreasing position, it must have been stationary. So MVT does seem to indicate it. We could prove it by saying something like, now here's the hard part, because you have two rows, people frequently get mixed up in saying what's continuous and differentiable. What am I applying MVT to? Position or velocity? Position, okay? So I need to say position is continuous and differentiable, not that differentiable, and differentiable. So by MVT, there is a C in, we said 0 to 8, right? Where or such that. All right, now give me the MVT here. What prime? No F, there's no F here. X prime, which is the same as V is equal to, now we talk average rate of change, X at 8, the average rate of change over the interval, 0 to 8 was, oh, it should be X prime at T, it should be X prime at C, right? And therefore V at C. There's got to be a place where the derivative of position, which is velocity, was 0. You see? You try. Velocity is differentiable and acceleration is continuous. It's a bad problem. Physics people, you probably are hating me. Is velocity different? Is it possible to go from a velocity of 10 to a velocity of 0 without passing through everything in between? I'll have to redo this. We'll talk about that later. I'll get up my notes from it. I talked to Mr. Phelps for like an afternoon about all this stuff, so I'll talk about it. But that's right. It does the job for the problem. Show there's a time when A equals 0. Did you get it? Yes? No? Okay. To show a time when A equals 0, does IVT work for A? I feel like we could use IVT right in there between 7 and 8 and say, yeah, A has to be 0. Did you use MVT? By saying V prime went negative and then positive, so A must have been 0? Is that what you said? Oh, that's rough. That's hard. I would have looked at IVT, but okay, good job, overachiever. A is continuous, and A equals 0 is between A at 7, which is -1, and A at 9, which is +3. So there must be a time in 7 to 9 when A equals 0. It's probably the easiest way to go. Yeah? By IVT. Now B, 6 is not obvious in the table. There is no reason to indicate looking at the A row why A would be 6. 6 isn't anywhere in there, nor is it enclosed by any of those values, yeah? And yet, there is a place where the change in velocity over an interval is 6. Where? And I think, isn't there? I thought there was. Isn't there? Thanks for the help. Here we go. Let's see. Here, right there. Boom. Look at those guys. What's the overall average change in velocity over that interval? Of 12/2. So an overall change of 6. So it feels like the answer is yes to this. Do I say A is continuous and differentiable or V is continuous and differentiable? V. V is continuous and differentiable. So by MVT, there is a C in 7 to 9 where V prime, which equals, that's C, V prime at C, which would equal acceleration at C, is change in velocity over that interval, and that is, yeah? All right, these are a couple of great AP problems, some multiple choice, but mostly free response. That would be good practice. You'll love them. Have fun with that. Questions on last night's homework? Yes?
Like, there's some problems on the
Then
So
you
then what
would,
do? Just write.
so that you would say it's not differentiable, so MVT is not applied.
Okay, so that would be like the whole problem.
Yep. Okay. All right, questions on
5.
5,
2.
2, 1, 4. 5, 2, 1, 4. All right. Really? That would be the first one as well. Okay, 5 is replaced. That's the greatest danger function, yeah?
No,
Isn't it? Yeah, you guys need to do
I don't even know what that is.
Yeah, so part of the problem might be, I don't even know what that means.
Yeah. That's exactly what it is.
All right, this one I just threw in there for a little review. It's at the end of the green book. Do you remember what that? It's not like super absolute value or anything, nor is it a matrix. It is the greatest integer function.
I lose.
Does that ring a bell? Or still, nope, nothing. Okay, so here, draw yourself a little picture. The greatest integer function is something that does something. It goes like this. Whatever you put in, you spit out the greatest integer less than or equal to what you put in. So if you put in 0, what's the greatest integer less than or equal to 0? 0. If you put in 4, what's the greatest integer less than or equal to a 4? Okay, so you have to go to a whole number. So what's the greatest integer? Think of 1/4 in the number line. What's the first whole number you would come to that's less than a 4? 0, yeah. What's the greatest integer less than or equal to a half? 0, 0, 0. This is the step function, and it stays there until you put in 1. Then when I say, hey, what's the greatest integer less than or equal to 1? Then you'd say, oh, or equal to, it must be 1. Right? So this is what the greatest integer function looks like. It's the step function. Okay? Now, with that picture, the question becomes pretty easy. Prove it's not differentiable at 0. Well, what's the first condition for differentiability? Continuity. It's not continuous at 0. So you would say something like, you can't just say, hey, it's not continuous, so forget you. You know, you have to say why you say it's not continuous. The limit as x goes to 0 from the left of the function. What is it? If I approach 0 from the left, the y value is -1. What's the limit as x approaches 0 from the right? 0. -1 is not equal to 0, so f is not continuous and therefore not differentiable. Okay. All right. Question 2. By the way, that greatest integer function is a valuable one, especially if you're in programming. If you are making a program where you couldn't spit out a decimal value, whatever. Say you're a bus dispatcher, and you know they put in how many students you have, and you spit out how many buses you'll need. Well, you can't say, yeah, you'll need 7.2 buses. You would want to program it so it would round to the nearest whole number. The greatest integer function is off the programming software to do that. So it's of some value. Question on 2. 2 is, yeah, this one I kicked my butt the first time I taught this book, but I didn't read carefully, and that might be the problem. Okay, so the volume of that, which, by the way, you could develop this formula with volumes of revolution, pi RH squared minus 1/3 pi h cubed, where r is the radius of the surface, and h is the height of it. Oh no, sorry, that's where my problem was. I assumed r was the radius of the fluid. R is the radius of the bowl. H is the height of the fluid. And that is important. Because R, is it varying or constant? R is constant. It does not vary. R relates to the shape of the bowl. Only H is the variable. So when it says punch flows in, the radius, you're given that the radius is 14 inches and it's flowing in at 1 cubic inch per second. So you're given R is 14, which is constant. It's always 14. It's not the radius of the surface. And if it flows in at a rate, then that's the volume changing in a positive way. So interpret that with calculus. dV dt is 1 cubic inch per second. Like that, yeah? They want How fast is the punch bowl rising when the punch is halfway up to the top? If they want how fast the punch is rising, then they want how fast the height is changing with time at the instant when it's halfway up the bowl. What does that imply numerically? That the height is, if the radius is 14, then it's halfway up when the height is 7. Okay, the height isn't always 7, that's just the instant they ask. All right, so here's the equation. Surely we want to differentiate with respect to time. By far, the problem that I had was I thought that both, or this had 3 variables. It does not. Volume varies, height varies, but R does not vary. You should understand and put in that the radius is constant, 14, so that when you differentiate things go much better. dV dt is, the derivative on this first guy is 14 pi stays, and what's the derivative on h squared? 2h dh dt, yes indeed. And minus pi over 3 times, and what's the derivative of h cubed? H squared d h dt. From there, you're probably rolling. You can substitute and solve, or solve and substitute. We know dV dt is 1. H at the instant is 7, so this is 14 times 2 times 7 pi dH dt minus 49 pi dH dt. You could combine like terms and then divide, and you're on your way. You follow? Finish it. 1. Question on 1. There's one still question. You ever asked that? Yes. Okay, this is meant to set the stage for set 88, which is a big idea of calculus, but it builds on this pre-calculus idea of exponential growth. The rate of increase in the material is exponential. Exponential growth looks a little something like this. When time equals 0, there were 30 bacteria. You're given that A initial is 30, and A 10 is 100.
Please rise for the Pledge of Allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay.
National Junior Honor Society will be selling Dairy Queen blizzards after school
So I
tomorrow.
can put this
Plan to
in.
start your afternoon off at school with a blizzard. We will have blizzards.
And then I can use this to find K.
Curtain, open tomorrow at 10 p.m. Support your performing arts by attending on 16th, 16th.
100 equals 30 e to the
Tickets are $8 and can be purchased
K
online.
times
Or
10.
visit devilmusical.feedyourself.biz for more information.
Are you good in school? Do you like to help others? We are desperately short of peer tutors. Please see Mr. Schmidt if you'd like to help out with this program. Or go to Dublin website, click on academics, and fill out the peer tutor application.
Attention 8th through 12th grade boys. Our boys volleyball team needs a few more players. If you like playing in the Summer Slam volleyball tournament every year, then our volleyball team is the place for you. Talk to Mr. Powers to get more information. Join before it's too late. Tryouts are Tuesdays from 7 to 9 p.m. Come out and join the fun.
Yeah, I am trying to
Senior
be
high
sort of
school. Eligible juniors and seniors, National Honor Society survey questions are due to Miss Stevenson by Tuesday, February 19th. Don't forget.
Do you have what it takes to be a leader? Do you have a week to spend this summer at UCCS to shape your life? The American Legion is offering
here we go.
offers young men completing their junior year of high school an opportunity to learn more about our government by attending Colorado Boys School.
First thing, we get that to 3 decibels and round it to the nearest whole bacteria.
Ladies, are you up for a challenge? Do you want to develop leadership skills, confidence, and learn more about our government? The American Legion Auxiliary is offering a week at UNC this summer to the rising female teachers.
For you?
Colorado Girls State is a free government and
So
action
good
learning
question. I'll
opportunity.
explain it. We'll do it in a minute.
Interest is self by counseling.
Junior high students, middle school tests will start on Monday, April 3rd. Practices will be at various locations throughout the week, with matches on Saturday. We have all known from experience that we get
So it's
for a flyer and
best to
have a great day.
hear. So I think it's easiest if you just make it flat. So I need to graph it in a way that I have 3 flat spots in between. 1, 2, 3. Okay, you bet. So the question is, what are we going to do about that test? And is anybody not taking that test still? All right, those people that haven't taken it yet, they're obviously going to have to make it their job. That's what it is. So here's the deal, yo. Tomorrow you'll be happy to know that there is no problem set. Tomorrow during the 35-minute class, you will have the whole period to work on test corrections, and I will give you half points back on everything you miss. That is a major bone thrown to you, because if you, for example, got to 60%, then you could get your grade up to 80%. Yeah, 40% difference to be back. You could get points back. So that is tomorrow. I will stipulate this. All I require is that your corrections are correct. Yes, I can give you points back for more correct. So please, I will help you. I was thinking I'll have a section of this up here. If you want to go to the free responses and small group here. I was thinking about putting some of the other students back in little places there where they can help individually.
Yeah. Wait, can we look at your presentation?
Thank you. Did you look at
Just cherry? Mine also didn't say.
Have a lovely day.
Anyone?